Our next speaker is Pablo Hevia-Koch. Pablo is acting head of the Renewable Integration and Secure Electricity at the unit at the International Energy Agency. And today, Pablo will talk about electricity markets, and in particular, how their design should support innovation in the energy transition. Welcome, Pablo. The floor is yours.
Thank you very much. This is working, yeah, perfect. That's going to be a very tough act to follow. Unfortunately, my slides are not as cool as yours, but I really appreciated your presentation and the way that you bring a bigger picture. I want to start, first of all, by thank you very much for having me here. And actually, I think that when they invited me, they did not know that since I was quite young, I've been really much a Linux nerd, lover. So when I was 14, trying to break my head installing Slackware for the first time, I never thought that I would have the chance to speak at a Linux Foundation Summit event. So thank you so much for that. And I'm going to be giving you a bit of a perspective on the energy sector, on where do we stand today, from the perspective of the International Energy Agency. And we're an intergovernmental organization that works globally with developed economies, emerging economies, on topics of energy, security, decarbonization, affordability. My background is a bit strange. Actually, I started as an electrical engineer, but focusing on AI. So in the early 2000s, I was working with a lot of natural language processing, autonomous navigation. Then I moved into the topic of energy and climate and ended up doing a PhD in economics. So I hope that when I speak today, I can try to bridge the gap. Because I remember when I was an engineer, and they used to tell me, well, economics is kind of for people that don't know what they're doing, they don't know math. I found it a bit short-sighted. And I think that when we look at things in the energy sector, we're going to see that you cannot solve one problem without the other. Now, where do we stand today? We stand that we have targets in terms of decarbonization. We're looking at trying to achieve net zero emissions by 2050. And that will require a lot of effort across different sectors. One of these sectors is electricity. And if you look in this graph, what we're going to see is that electricity will be the first sector to decarbonize if we're on path with our net zero goals. Why? First of all, because it's a bit easier. We have more technologies that can help us remove carbon in the process of electricity generation, but also because through electrification, we can leverage electricity to decarbonize other sectors and try to take advantage of this. Now, the next decade is really where we're going to see a massive clean energy expansion. We're hoping to see massive investment changes in PV and wind, solar PV and wind, around 4 times as much as we had in 2020. We are going to see, without a doubt, and we're already seeing it, a significant increase in electric vehicles, electric cars, and we're expecting to see a decrease in the energy intensity per GDP. And that basically means trying to reduce how much energy we're utilizing for creating economic activity. Now, the important thing to note is that many of the technologies that we're going to need in the short term are already there. It's a question about implementation. Now, if you remember my last slide, it doesn't stop in 2030. It continues. And we're going to need a transformation of our energy systems and the technologies that we're going to use for that. Some of them don't even exist. Some of them exist at very early stages. And this is very much driven because the power sector is changing, and we've seen it quite a bit. We've been moving from a traditional system that is centralized and dispatchable, where you can operate your power plants whenever you want. It's very much centrally planned, one energy flow, one-way energy flows, one-way communication flows, to a sector where, well, there's supposed to be another slide here. There you go. That happens when you put animations and things, they never work. Which is actually decentralized, where you have variable generation that you cannot control, where in technical terms, you cannot rely on big generators rotating to provide you with system inertia, and where you're going to have multiple actors. It's not longer one big company that produces energy and then distributes it downwards, but you actually have distributed generation, distributed services, and things like that. And as you will see, we're going to be relying much more on open networks, on many devices. And on top of that, unfortunately, we're at a stage where we can see that climate change is happening. And as climate change happens, it will change many of the assumptions that we have on how technologies operate and how resilient they are. Now, as I mentioned before, innovation is going to be very important. In our analysis, what we've seen is that half of the emissions that we need to reduce by 2050 require technology development, and this is across all sectors. Half of it is technologies that are already in the market, but the other half, we're going to need to figure it out. We're going to need more R&D, we're going to need more investment in demonstration projects, in pilots, and then we're going to need to move these technologies and these projects from pilots to massive scale-up and implementation. And one way to look at it, and this is very much an IA approach to things, is to really look at the data, look at the numbers, do the analysis. So, for example, we took a system, Indonesia, and we're comparing how does the electricity sector in Indonesia will operate in 2019, how did it operate, sorry, and how would it look in 2050 based on their pledges and scenarios. And one thing to note is the bottom bar, energy. Traditionally, in the bottom left, you can see that most of the energy comes from coal. It has some gas, some hydro, some geothermal. But there are other services that are needed, and this is something, of course, you know. You need inertia for the system, you need system stability, you need ramping flexibility, you need adequacy. And in 2019, you see a very traditional system in which most of the services that are needed are provided by the same technologies that provide you energy. So it means that the same generator that is generating electricity is the one that provides you adequacy, is the one that provides you flexibility. As we decarbonize and we reach our announced pledges by 2050, this is no longer the case. And the technologies that will provide energy are not the same technologies that are going to provide you with inertia, stability. And for those of you that have some insights into how we trade electricity today in most markets, this already shows a bit of a challenge, because today we pay mostly generators based on how much electricity you produce or consume from them. But if the generators or the services that are providing inertia are not the same ones that are really selling you energy, then you're going to have a problem. Now, why do I want to talk about markets? And the first important thing here is this is not really a question about principles, but because most of the electricity today is generated and consumed in systems that have electricity markets. And markets are really going to define the ability to scale up and utilize new technologies, or if these technologies are going to be stuck in states of permanent pilot development. Now, how do I see markets? And I think that markets can be a bit spooky for some people or a bit undefined. And really, from my perspective, markets are just like a multi-agent optimization algorithm. You have a lot of different actors that are coming together in a complex system, and they're optimizing a certain objective function. Now, from the perspective of what is it that you would like to achieve, you have different objectives. Security, in terms of energy security. You want to keep the lights on. You want to survive the energy crisis when a war happens, for example, when prices go up, when there is wildfires, when there is natural disasters. You want to really take care of climate change and decarbonize your system. You need to drive the investment that is going to install the infrastructure that is needed. And you want to do this in an affordable manner. As we move into these complex systems, this new paradigm of distributed systems, of open communication, markets have become one of the main ways in which we optimize or co-optimize these different objectives, ideally at the same time and at different time scales. But there's always an issue, isn't it? And I don't know if somebody has ever heard of the Cobra effect or Goodhart's law. And there's a story, probably apocryphal, but I find it a fun story, so I'm going to tell it anyway. And it's about a policy for removing cobras in India. Cobras, venomous, they wanted to remove them, so they created an incentive policy. And the incentive was that if you bring me the head of a dead cobra, I'm going to pay you some money for doing the service. Well, of course, for those of you that are on optimization, you realize that optimization algorithms find a way to solve the problem in really the most efficient manner based on your objective solution, not on what you want to happen. And what happened here is that this incentive really drove people to breed cobras. You capture a cobra, you breed it, you get a lot of cobras, you chop some of their heads, you sell them for profit. Now, of course, what happens when they realize? They say, well, we need to remove this incentive system. They remove the incentive system, and that means that, of course, now you have a lot of cobras. What do? You release them. So actually, after the cobra elimination program. You end up with many more cobras in the wild. This is something that happens in all optimization problems. I'm sure that you've seen it, and markets are no stranger to this. This happens very often. And to prove that it happens very often, I want to give you a very specific example. PJM is a market in the United States, and in 2014, there was a polar vortex. This means that there was very much demand for heating, very cold days, and that means that electricity demand goes up, and it went up by 33%. That's a lot. Now, PJM, of course, in preparation for this, they have something called a capacity market. Capacity market is a system in which you pay generators just for existing, you know, and the idea is that maybe they're not going to be generating electricity, but when stuff like this happens, you have some generators that are ready to come in and supply the demand. Now, what happens? In reality, you don't want these generators to be there all the time. You need them to be there when you need them. So what happened in reality was that actually out of these many generators that had received capacity payments, several of these, around 22%, were not available on the days where the polar vortex hit. And this is, of course, catastrophic, because you've been paying generators to be available, and when you really need them, they're not there. Why? Because the payment was based on a yearly average. There were penalties for non-performance, but actually, they were there almost all of the year. They were only not there for 1 week, so the penalty is very small. And this is the kind of example that shows what happens when you don't really manage to find an objective function that really reflects what is it that you want. Now, this is not always negative, so I want to provide some positive examples of how you can do a bit better. And one of the examples has to do with geographical resolution. And that means that basically, here we have Texas, what we call the Texas system. And Texas transitioned from a system in which they had price zones. So that means that every one of the blocks on the left of the different colors, blue, yellow, orange, green, they had the same price. And that meant that all of the signals that come from the market that indicate demand or supply were the same on each one of these zones. And they decided to move to a nodal system in which they increased a lot the geographical resolution, a bit more like on the right-hand side. And then in the right-hand side, what it shows is every point in that system has a different price, so much higher resolution. And the idea was that this will reflect better through prices the needs and the physical reality underneath the system. And why does this matter? Well, Texas actually has one of the largest amounts of renewable energy in the United States. And on the left-hand side, you see a map with many colors. The important thing here is that the areas that have the most wind are on purple in the top part, what they call the panhandle. And the further you get into brown and green, there's less wind available. And then you may say, okay, so the idea is that you put wind turbines in the areas that they have more wind, right? Wrong. You don't need to put wind turbines where there's more wind. You need to put wind turbines where you need them. And the reality is that you have a lot of wind in the panhandle, but you have no demand, you know? So if you put a lot of electricity generation up in the north where you have a lot of wind, that is great, but then you're not going to be serving demand that is there. You need to transport it and congest all of the lines all the way to the demand centers in the south. So by increasing geographical resolution of the market system, what they were able to show is through prices that if you look at the prices on the right, the light blue line represents the prices in the panhandle. And basically, the prices are much lower. And this indicates that actually, that's not really a good place where you want to put more generation. You want to put generation in the places like the south, where the prices are higher, and when you really need the generation. And this is a concept that we need to become much, much more acquainted with, and that is the optimization of the system as a whole. And be aware that sometimes what may be, and of course you know it, you work on software, you do optimization, minimum or local maxima are not really always the best solution when you're optimizing the whole system. Now, geography can be a bit easier to understand, but as we move towards technologies that are more emergent, like for example batteries, this gets a bit more complicated. And there's a lot of fancy words here like wholesale arbitrage, ancillary services, but the idea is that each one of these columns represent different services and value streams where batteries can provide their value to the system. Mhm. Today, most batteries in most of the world, not everywhere, are remunerated. They receive money by selling electricity that they stored. So you buy electricity from the market, you save it, and then you sell it afterwards, ideally at a higher price, and you get paid for that. That is the very basic market design today. If you want to really optimize deployment of battery storage, for example, you need to find ways to remunerate them by the actual value they provide, the value that they give for transmission support. What does that mean? That sometimes you can build a battery, and building a battery in a certain place will save you from having to build a very complicated or expensive transmission line or distribution line. They can also provide other services that are not just electricity generation, but regulation of frequency and voltage control and rapid response. So that means that if we really want to see new technologies like batteries come up, we need to find the right incentives to bring them up. And why do I find this very important today? I saw the agenda today, and the talks are really fascinating. And it's the kind of projects and models and developments that are really going to bring value into decarbonization of the energy sector. Important thing to note is they don't exist in a technological vacuum. They exist into something that people very often say with a bit of a boring voice, which is a regulatory framework. And we need to understand that if we want to bring a lot of these new developments to a place where they can really be transformative, we need to make sure that we step up our market design, our policy design, our framework, the world under which these new developments will come, to be allowing them to provide the value that they bring. And a typical example is electric vehicles, And I'm sure that electric vehicles is something that many of you are aware of the technical benefits that they can bring. We talk about things like vehicle to grid. Oh yeah, we could use maybe vehicles, batteries to support the grids during times of need, so maybe you can save some energy there, and then you can take it out when the system needs it. And yeah, our analysis shows that they can actually reduce peak demand by half if you manage their charging, So if you have intelligent systems that will take vehicles that are on a certain network and charge them in a way that doesn't bring one single peak, but you distribute them over time. Now the big question is, why would we do them? Why would we do it? If you own a vehicle, why would you allow your vehicle to be utilized for this? One option, what you call command and control, is that you're forced to do it. But the reality is that when you have a lot of these regulations that are very direct and say, just do it, what you're doing is you're choosing and picking winners. And we've seen it before. What happens when you have new technologies? Do you need to include them also in specific cases? Is it fair to try to centrally control the operation of all of the assets? I mean, it's a very complicated problem. And that's why the design of incentives needs to be aligned with what you want to happen. How can you, for example, remunerate or coordinate the utilization of these vehicles? And this was a question that happened even with solar panels when you put them on rooftops. What is the fair price that you should get when this electricity that is generated in your house goes back into the grid? So that kind of question is really what acts as a lock between the possibility of taking technologies that are really cool into deploying them to be really transformational of the power sector. And this doesn't happen just with technologies, but also on the way that we operate companies and the way that we feed electricity into our companies. And I think one example of this is clean procurement. I love how I cut myself my own words in the slide, sorry for that. Sorry. The question here is, I'm missing a lot of words in the graph, so this is going to be a bit complicated to explain, but do you know what clean procurement is? There's many companies, particularly energy-intensive companies, I can see people from Google smiling here, that have their own climate and energy targets. And that means that big companies, they're making commitments in which they say, okay, from now on, all of our electricity needs to come from green sources or clean energy sources. Now, the way that you can account for this is a bit different. You can look at how much energy you consumed in a year, and then you can buy yearly the same amount of energy coming from clean sources. You can do this accounting monthly, or you can actually look at a second by second and say on every second of the year, the exact amount of energy that I'm consuming needs to be produced at the same point in time by renewable sources. And as you increase the resolution of this commitment, what you're going to see, and this is going to be a bit complicated to explain, but in this first half, what we're seeing is a change in colors. You know, suddenly you have some dark blue that appears, suddenly you have some dark green, and this is a deployment of vehicles and batteries. So what we're seeing is that as we increase the resolution of these commitments, we're going to really be changing how the system operates. Which kind of technologies are going to appear? Is it going to be served just by renewable energy, which is the light blue, or is it going to be served by more emergent technologies? And I think the crux of the problem here is that, to realize that if we want to see new technologies, new methods, and innovation happen, we really need to create a framework in which not only we allow it to happen, but we incentivize it. And how can we incentivize it? What I see is that a lot of the innovative technologies and innovative methods, they have value already. They are better in many ways. They don't need help. They need a framework that allows them to show that value and that allows them to be remunerated and to receive the benefits of the value that they provide. And that's really the context in which, for me at least, it was very, very helpful to transition from a field where I was working exclusively on the cool innovative technologies, or at least for me, into a field where I try to how to make those technologies and methods happen in a broader scale. So in terms of the context that I'm giving, what I want you to know is that decarbonizing the power system is really what we're focusing on today. And the coming decade is really the make it or break it point. Now, this is already happening, but it needs to happen faster. And really, the fact that you're here means that you're in the right sector, in my opinion. This is really the place to make things happen. And remember, half of the technologies that we need all the way to 2050 are already there. So this already hints us at the fact that maybe the issue is not just that we need more technology, but we need to take the technologies that are already here and start using them to the full extent of their capabilities. And if that's really what we're driving for, we cannot separate our thinking from the regulatory framework, from the market design. And market design, funnily enough, in my opinion, shares a lot of the traits with the open source principles. Transparency, for example, you know, inclusive meritocracy, the idea that technology should be able to come in through their own value. The aspect of community, from the perspective that you want a community of energy. You want all actors to be able to access for buying and selling energy and providing their services. And what they call release early, release often, I would call it iterative process in terms of market design. There's no way that we're going to figure out today one market design that's going to take us all the way to 2050 perfectly. We're going to need to improve it. We're going to need to work it. We're going to need to see what works, what doesn't work. And we're going to need people like you that are on the technical side of things to participate in this discussion. You know, we cannot afford to separate technology from policy anymore. That's a big mistake. So if you really care about the impact that you're going to be making, please learn about both things. Policymakers cannot be completely away from technology. Technology people cannot be away from policy. We really need to bring this together. Thanks a lot for your time. If you have any questions, you can maybe catch me at the coffee break at some point. And I hope that you have a good summit. Thank you very much, Lucian.